So I was taking a look at the textbook and reading what we have in front of us. The textbook uses two examples of surveys, one in the Carson Desert and one in Mexico. Um, and I was, I'm not intimately familiar with those examples because I wasn't there. I mean, the author is obviously, which is why they put them in the book. But I thought, well, why not? Why not give you guys examples? Instead of using the book's examples, I can give you examples of projects that I've done because I'm much more familiar with them and can answer every question in detail. So I'm going to take a look at the chapter, and I'm only going to require you to know a portion of it at this point. I'll ask you to know all of the definitions and really only the first part of the textbook prior to coming down, prior to the survey, the Carson Desert survey. But I'll take a look and I'll post that on the website so that there's no confusion. So I'm going to give you an example today of survey that I did a few years ago with a geophysicist in Sweden. And this paper we gave at SAGIP, which is a Society of Geologists and Petroleum Engineers mostly. This is for this presentation was given to geologists. Of course, I'll tailor it to you at this point. My colleague, William Sauk, is a geophysicist. And today we'll be talking about the use of geophysical methods to search underground. That is to say, we are doing remote sensing. We are going to be using a proton or a cesium vapor magnetometer and an EM38, which is an electromagnetic conductivity sensor. These types of high-tech devices can be used to try to look underground before you excavate. In Samoa a few years ago, we also did the same thing, and there we used a ground-penetrating radar. So you have a lot of different tools that you can use, and I'll try to discuss what they are, and I'll just use this sort of as an example of one way that you can do a survey using remote sensing techniques like this. So I'll start with our objectives. I'll then talk a little bit about the regional and local setting that we're in, the methods we used. I'll give you some of our results, and then I'll tell you what we want to do next. So I had students come with me this year that we did this, and they were all taking independent study. It wasn't actually a field school course. We don't have a field school at this university, but this particular year I took 4 students with me into the field, and we wanted to teach them how to do these things. We wanted to test the magnetic method on Gotland, which until recently wasn't used very much. Now the magnetic method is going to be this, the magnetometer. I'll explain a little bit more about a magnetometer and what they do, but very little of it has been used over there, so we thought we'd give it a try. The site I'm looking at, and I'll tell you a little bit about the site in a second, has we wanted to make sure that we could identify the living floors at this location, and we wanted to search for anomalies outside the house walls where metal and glass works might be found, and we wanted to see how much data we could gather in about 1 week. Here's the setting. We are in Gotland, which is an island right in between Sweden on the left and Estonia, Latvia on the right. So we're in the Baltic Sea. If you zoom out a little further, I don't have a map showing you a little further out. The Baltic Sea is north of Germany, more or less, and extends up there towards Latvia, Estonia, Russia be around the corner. On the left you have Sweden, and at the very top of the map you have Finland. So we're right there in this eastern Scandinavian portion. This island of Gotland was a very important location in the Middle Ages. You've heard of Vikings, probably. Every time I pick up a new book about Vikings, it's always got a lot of information on the archaeology of Gotland, even though sometimes they don't even mention that it comes from Gotland. Almost all of the stone artwork, for example, that the Vikings produced or Viking Age peoples produced comes from Gotland. There's these very characteristic stone graves that are associated with Vikings that are only found on Gotland. More silver or silver hoards have been found on Gotland than anywhere else in Scandinavia. Yet mostly what we hear out here in the West is about the Vikings attacking England. And that seems to be, the majority of what we know about Vikings. And I've discovered since I got into the business of studying Vikings that that's an artifact of the fact that we speak English, and the other people who speak English over there as their first written language, the English, have written very extensively about Vikings in English. But when you begin looking at all of the data that's out there in other languages, you realize that Vikings had a very broad footprint, and that this particular island might be one of the most important ones. Another thing that struck me about Vikings when I first started studying them was well, who were they before they were Vikings? We read a lot about, when you get into Viking Age studies, you read a lot about the Viking Age, when these folks just stormed out of nowhere and attacked England and attacked continental Europe, colonized as far west as the New World, far east as Russia, and south all the way down into Jerusalem. But there's very little discussion of, well, who were they? How did a Viking Age just begin at one moment in time? I mean, weren't they Vikings before then? What were they doing? And so I got interested in sort of the origin of Vikings, if you will. Where did they come from, and who were they? What were they about before the Viking Age? And that took me to this island called Gotland, where I believe much of what we consider Viking kind of got started. So the site we're looking at is right down here, right in the middle of this island, just off of one of the major highways. We'll zoom in on this a little bit. Out there in a farmer's field. The site we're going to be looking at is a site called Visne Angar. It is something Visne Angar had been recorded previously. Yes, sir.
How big is Scotland,
It is, I'm thinking in kilometers now. It is, let me see if there's a scale on this last map here. I'm thinking in kilometers. What does that say down there? 220 kilometers. Can somebody do the math on that real quick? 220 kilometers would be, it's about 200 kilometers long. Can somebody do the math on that? Can we convert kilometers to miles? It's big, but you can drive across it in an afternoon. Yes?
Is it really urbanized, or is it very rural?
It's very rural. It's a very rural place today. There's a major town on the northwestern side called Visby, and Visby has been a town since the 1100s or earlier. It's a lot of cruise ships pull in there. It's a touristy destination at Visby. It's a medieval town, and it still has medieval roads and medieval walls, and they capitalize on that image that they've got. But most people don't ever leave the town of Visby, and the rest of it's mostly rural, mostly sheep production, hay, some farms. There's a number of other towns on Visby that have some manufacturing. Other towns on Gotland that have some manufacturing. One of the things that's interesting is that this island it's made out of limestone. which I have on another slide, but it's a limestone island. It's a portion of the seafloor that was uplifted and buckled into an island. This, well, the rest of Scandinavia is mostly made out of granite, but the limestone comes off in these big slabs, and it's these slabs that form the basis for this Viking Age artwork. They would take these big slabs and turn them into monuments, and they would paint or carve these pictures on them, and that's possibly why they're unique to Gotland, is because Gotland is the place where this raw material is available, but also the same raw material can be used for making cement and whatnot. So there's a few cement plants there and lime works on Gotland as well. It's a very pleasant place to go, and it's a very sort of ancient. It's an old feeling place. It's very pleasant. So anyway, this farmer had this archaeological site on his property. Now, this archaeological site is not believed to be Viking Age. It's believed to be pre-Viking Age, but it's still visible. What you had on the surface was these rectangular stone outlines, and these rectangular stone outlines are believed to be house foundations, and there's about 10 or 12 in this area. Consequently, you have either a village or you have a rather large and centralized farm of some kind, if these are all house foundations, which I'm sure they are. A lot of archaeologists have investigated these things before, not these particular ones, but other ones, and all bets are that they are multi-purpose building foundations, typically for living, but also sometimes they find that they may have been used for housing livestock and whatnot. So there's quite a few just in this area. So since we can see them on the surface, we wanted to know what was under the surface. And that's why one of our first objectives there was to see if we could see the house foundations with our remote sensing techniques. I mean, we can see the house foundations with our eyeballs. So the question was, what do they look like when you pass over them with a magnetometer or a EM38? Because that would give us an idea of, well, what they might look like if they were buried. But perhaps more importantly, and that is that houses, because of the site formation processes we've discussed, houses tend to be cleaned on a regular basis. They're not full of debris all the time. It's not always, right? Some of you may have messy bedrooms, I don't know. But people clean their house. They don't throw away their food remains typically in the house. They don't manufacture things and just leave the waste in the house. They tend to clean all that stuff up. So houses may actually not have as much stuff in it as you would like as an archaeologist to figure out what they were doing. And I mentioned last week that any given archaeological site is not going to contain the complete range of activities that people were engaged in. Well, the same can be thought of within a site. If we excavate a house, we're not going to get the complete range of activities that could have taken place at this village or farm. So we wanted to look in between houses. Maybe we'd find a trash dump. Maybe we could find a cache or a storage or a place where they were manufacturing something. These were all possibilities. So, and you can't see those things at the surface, but we hoped to be able to see them underground. So this limestone, the situation is this: we have this limestone island that during the Ice Age was overridden by an ice sheet, and at the end of the Ice Age, the ice sheets began to retreat. We're far enough north that this place wasn't ice-free until around 6,000 years ago. At that time, when the ice sheets fell back, they dropped a lot of debris out of them. If you can imagine these sort of ice sheets pushing forward out of the north, grinding down the continent north of them, they override. When they override Gotland, they're full of rocks and debris that they had carried with them from in many cases, far off places. But when all that ice melts, all that stuff just falls down onto the surface. We call that glacial drift. And many places in Gotland are not limestone on the ground. Instead, they're covered by sometimes up to 5 meters thick of glacial debris. This particular site was built on a hillside that was made out of this glacial debris. What that means is that it was well drained. It was a place, probably from my sort of ecological perspective, that they selected on purpose because it was well drained. If it's made out of the gravels and sands of glacial deposits, as opposed to being built right on limestone, which is not porous and would be prone to flooding, right? So I've talked a little bit about the human history. So this is in a time period we call the Iron Age. If you think about the time, the Viking Age begins, by the way, around 800 AD, right? Okay, around 800 AD, you have Vikings that attack Europe, and that's when we say the Viking Age begins. You may recall from your history books that around the turn of the millennia before, you had the Roman Empire. The Roman Empire, by the way, collapses at around 400 AD. And that's far to the south, of course. But that period between 400 AD and 800 AD, when the Vikings come back, is a sort of poorly known period in European history. The collapse of the Roman Empire created a power vacuum throughout Europe, and there was a lot of probably combat, ambiguity, ethnic groups fighting one over the other for political control. I still refer to this time as the Dark Ages, even though that's not as politically correct as some would like to have it. But it's that period when this site was occupied. Now, we're way far north in Sweden, and there wasn't probably a whole lot of conflict here. But one of the things that's interesting is that you do find a lot of Roman trade goods from this period. The Northerners, they knew about Rome. Rome was, say, the world's superpower. And even though the Romans didn't know about Gotland, because the Roman world didn't extend up into Scandinavia, the Scandinavians knew about them. And they have a lot of Roman trade goods that you find. That's the time period we're looking at. Now, we call this Iron Age farming. Viking farms and culture are then on top of this. Skip the next line, metal and glass working. We were hoping to find some evidence of that. A little bit about the history of Gotland, and that is that there's a real famous medieval battle there. It takes place in 1361 when Gotland was in a very, very important trading center, and the people of Gotland revolted against the city of Visby. And they attacked Visby because Visby was being run by bureaucrats. And interestingly enough, there's still kind of this relationship today, this uneasy relationship between the rest of the island and Visby. Another thing to be aware of is that pot hunters, or I shouldn't call them pot hunters, collectors, people with metal detectors have gone out and collected a lot all over the island. It's now illegal in Sweden to use a metal detector on the island, but a lot of your sites have been looted. The equipment we used was a cesium vapor magnetometer. That's the first one, Geometrics G858CS vapor gradiometer. A gradiometer is a special type of magnetometer that has two sensors built into it, a lower sensor and an upper sensor. And instead of just having one sensor with the strength, when you have one magnetometer sensor, it works a little bit like a metal detector, except for it's actually detecting changes in the Earth's magnetic field. But when you have just one of them, you get say a strong hit or a weak hit, but you can't tell how deep something is beneath the ground, because you could have something that's really big, that's deep below ground, or you can have something shallow that's right at the surface. And you can't tell the difference when you only have one sensor. But when you have two sensors, you are able to sort of mathematically, when you have about a meter between them, you're able to mathematically calculate about the approximate depth of what it is that you're finding. So we have this a rather nice instrument that would tell us the depth of what we were looking at. We also have an EM38, this detects conductivity in the ground. Whereas a magnetometer looks exclusively at magnetic fields, an EM38 will detect how much electricity, if you put electricity through the ground, how quickly and how easily does it transmit from one place to the other. This makes it really useful for finding anything that conducts electricity, things like gold or silver, which sometimes are not detectable by a standard because they're non-magnetic. They sometimes aren't easily found by a magnetometer. What we did was we divided the site area into survey blocks because we knew we couldn't do the whole site. We decided we were going to have to sample the site. The thing about sampling, the that's right. That's all right. It was just distracting for a moment there. The textbook talks about this huge area in Carson Desert, and they decide to do a random sample. The purpose of a random sample is to make sure that the archaeologist themselves doesn't bias the result by only surveying where they think good archaeological materials will be located. Because they want to get an idea of how the entire landscape was being used. Now, we didn't want to know how the landscape was being used. We knew that the site existed or where it existed, and we specifically wanted to look between buildings. So we did not conduct a random sample. What we did was we selected arbitrary portions of the site to survey. What we can't say, therefore, is that whatever we found is representative of the entire site as a whole. But we would never do that anyway. We already know that our sample represents the inhabited area of the site and does not represent activities throughout the entire site, if that makes any sense. So we didn't do a random sample. We instead selected the areas we wanted to look at. We selected house foundations, and we selected areas between house foundations. What you do with whether you're surveying on foot or whether you're surveying with an instrument, you do what is called a transect. A transect is a pass, if you will, over an archaeological site. If we were going to go do an archaeological survey together and we were going to look with our eyes, we might say the site is that way, we might form a straight line going this way with 5 meters between us or 10 meters between us or 50 meters between us, and then we would all walk in this direction and be looking with our eyes. We don't walk hand to hand. We walk at a greater spacing than that. So typically even when you say archaeologists have surveyed this area, there's still a chance that obviously they're going to miss things. If there's 5 meters between us, that's 25 feet, right? 5 to 3, 15, 20, 25 feet between them. Well, can I really see everything I might need to find if there's that much distance between us? That's debatable. That's essentially part of the sample that we don't ever talk about. You do the same thing with instruments. If you have a magnetometer, you drag that along a line, and then you come back and you do it again at some distance. What you're trying to do here is balance time and money. If you have an infinite amount of time, then you could use your magnetometer to create a very fine-grained map of the subsurface. We chose 0.5 meter intervals. So we would do a line across, and then we would come back 0.5 meter down the list. In any case, each one of those passes is referred to as a transect. This last part is a technical detail, 10 readings per second, something that other geologists might be interested in. Here's what our site looked like from an aerial view. This is from Google Earth. It pretty much looked like that when we excavated there. You see there's two fields. There's two open fields that are in hay production. And then there's this one field on your lower left that is not, that it's an open woodland habitat. That's where the bulk of the house foundations are located. There's also a few across the road where it says number 9 over there. It's actually more than this, but these are the areas that we decided to survey, and we surveyed 9 areas. This area we picked along the edge of that hayfield. We did that because the landowner would allow us to do it. He didn't want us surveying all over his growing hayfield, but he did allow us to do a survey along the edge of it. We hoped that we might find there some more activities that would that had taken place outside the village, just outside the village area. But and this one on this side, this field down here in the lower right, we did not have permission to go into. Yeah.
To find those little stumps y'all found,
Mm-hmm.
the limestone,
Mm-hmm.
y'all did do the passes against that entire area just to find them, the sites.
Yeah, the limestone pieces that we're talking about that they paint into these large paintings, those are not what we were looking for.
You find the foundation, right?
We were looking for foundation pieces. This is what a foundation would look like from the side. It would look like a mound of rocks. Now, I don't have, unfortunately, it's hard to show this in a two-dimensional picture. But if you walk up on that mound, you'll see that on the inside there's a rectangular depression, which would have marked relatively where the inside of the house was. So really what you have these walls that are collapsed over 1,000 years, say, since they were inhabited, 1,500 years even, possibly. Through all of the natural processes that we've talked about and cultural processes. That means for the 1,500 years, farmers coming in here or pot hunters coming in here and digging in the walls falling over, tree tip-ups happening. You end up with an amount, sort of this, instead of a wall, a low wall, you end up with just a pile of rocks that's approximately oval, really, if you look at it from above. But at one time, they were roughly rectangular, maybe sub-rectangular. And the walls, there's enough rock in these walls to suggest that they might have been 2 to 4 feet high. This is Bill Sauk, one of the geophysicists, setting up the cesium vapor magnetometer. You'll see it has those 2 white canisters at the right. Those are the upper and lower sensors. And this is one of our students walking a single transect. And the data is recorded into this box that he's carrying. And you take this information and you download it and you analyze it with a computer program made for that purpose. This particular survey transect is being done outside of a house. Turned out that surveying the houses was difficult because ideally you keep the instrument at a constant height when you're dragging it over the ground, which is very easy when there's nothing on the ground. But when you have to survey over a mound, that means you're not keeping the sensors at a constant height. You're constantly changing the height of the sensor as you walk over something. And it turns out to be incredibly difficult. There's another student. I guess I wanted to get all my students into these pictures. So that was one of the students. She's using the EM38, which is an electromagnetic conductivity sensor. It works in a very similar fashion, except for what it's doing. It fires out impulses from the front, and they are read by the back. So we're looking at milliseconds of change between one sensor and the back sensor. This is a student who is working to clear one of the walls. This picture was intended to give you an idea of what a wall would look like in cross-section, but again, they're really hard to capture But if you can imagine this side going up and then down on the outside, a little deeper on the outside than it is on the inside. But this gives you an idea of, and then inside you have this flat area, which presumably is a living, work, or storage space. So now I can show you what some of the results look like. This is what a typical house foundation would look like with the gradiometer. Pretty easy to see. The boulders are magnetic. They have magnetic inclusions in them, which allow them to be identified very easily. Recall that this is a limestone island, so you might ask, well, where do all these boulders come from? The answer is these are the glacial till. These are non-local stones that were brought there through natural action and deposited on the island 8,000 years ago. People would then go out and collect those stones and form them into these rectangular areas, making up their walls of their house. This is the same feature with the gradiometer, with the EM38. Not quite as easy to see, but nonetheless does show that some of the boulders show up quite nicely, and we think we could probably use this to find something outside. Here was another pass by the magnetometer. This one using a different. This is another pass by the EM38. This time using the 1 meter coil spacing, which detects deeper, looks deeper down, and we found this really sharp hit up there. So there's something there that has a tremendous amount of conductivity right in one of the walls, or right beneath one of the walls. Because the 1 meter coil spacing means this is the part of the instrument that measures something that's deeper down. Although that's such a strong hit that it could still be shallow. You can see on this one, these are the same. Oops, you can see where they kind of overlap one another. This is the same scale. It's right there. We took a look at it, and unfortunately, we found that it was a natural rock that was so full of magnetic materials. It was not a man-made artifact, which is unfortunate. So we looked at another house, Block 9, house outline with a detached feature. This is an interesting one because you have this house, right? But then just outside to the upper left, you've got another set of something going on out there. That could be more boulders. It could be a fire pit or something going on outside. But that's something we wanted to go back and take a look at. This is another house foundation that we got with the 1 meter coil spacing, and unfortunately, this one we got really interesting readings. There's this large, highly magnetic thing going right through the middle. My first inclination was to think, well, maybe there's a pipeline there, but you couldn't put a pipeline through a house, right? Not preserve the foundation. Anyway, the answer was really easy. There's actually power lines right over our head that bummer. Should have noticed. These last two areas here I want to show you are places that we decided would be, this is where we decided to excavate the following year. Those two yellow arrows, the one on the left arrow was the largest house foundation. It was over 20 meters long and about 8 to 12 meters wide. Would have been a very, very large structure. And then this other structure on the right was a strange, it looked like it had 2 rooms in a 2-room structure. And this is what we found. We found this house had 2 large anomalies, one outside the house in the upper left, and then one outside the house in the lower right. You can see that this outline, I think you can see that this house outline doesn't look perfectly rectangular. It looks a little bit oddly shaped, but you have to consider all the site formation processes that have been operating on it for 1,000+ years. It's essentially become deformed. The rocks are not in place. So remember, all we're doing at this point is looking. We're not actually digging, so we can't verify what we're seeing. This is only giving us clues as to what might be underground. The next slide shows the same exact site actually, but this time we're looking at a different instrument, and we're still getting the same high results. So this makes this a high priority target to go back and excavate. The place that had 2 rooms on it was interesting. We've got the square foundation clearly visible on the right, and then on the left you've got a series of other items. The red and blue hit, if you will, on the upper left there is showing us that's a strong positive and a negative pole. That means this is a field that is oriented in a particular direction, and the instrument hit it just right. So we're looking at something that's magnetic and is long and highly polarized. That's buried beneath the ground. Something like a metal pole or a stake or hopefully a sword or a spear, something along those lines. We got the same when we did a close-up of that with the gradiometer, the cesium vapor magnetometer. We got the same basic hit, and this was so it's both magnetic and conductive. Same object using the conductivity at a 1/2 meter spacing. The fields weren't nearly as interesting. The fields had individual spikes here and there. We're looking at the northern fields on the north side. Every now and again you'd find a hit, which would be incredibly difficult to find our way back to these locations. In hindsight, we probably should have put a shovel test in immediately. Whereas with the house foundations, we knew we could come back the following year, and with a good map of the house foundation, we'd be able to get right back to where those hits were. But in the field, we didn't have any good frame of reference, really. And we should have probably excavated those right then and there, but in a sort of an expedient fashion. But we didn't. So this data is probably useless at this point. So I learned a lot on this survey that you have to have if you're not going to excavate something immediately, you have to have very good control over where these readings are being taken. You need to mark them, and you need to either excavate them immediately or shoot them in with a very accurate mapping device, a total station, a survey instrument of some kind. Your GPS probably is not accurate enough. Your GPS on your cell phone, even an expensive GPS, without a base station isn't going to get you within but 2 or 3 meters. So that's not good enough either. We needed to have a very accurate way of getting back there. What I would do, though, is just shovel test it immediately. Dig a single shovel test straight down and see what you find. And this is just more examples of the little hits that we got in that field. There were no structures. I guess that's the key thing to remember, is that there were no structures. We just found individual hotspots. On the other hand, when we wanted to just see how efficient we could be, we actually walked over 16 kilometers of line, surveyed twice in 1 week. So this was a very efficient way of looking below the surface, which makes it very cost effective. Even though an instrument like this might cost $25,000, the fact that we are able to get so much done in a week, that kind of insight is hard to replace with just human beings randomly sampling and digging shovel tests in random locations. So our conclusions were that we found that the magnetic works well to outline structures. And even though people hadn't used it much before on the island, it seems to work very well and has a lot of potential. There are this massive sulfide glacial boulder, that was the one really strong hit. We have to be careful in identifying every hotspot as a cultural item, because we know for a fact that some of these glacial boulders have a certain chemistry that causes them to be highly magnetic and highly susceptible to charge transmission. We did find outlying features near the houses, which is exactly the kind of things that you want to find. We wanted to find, but we would have to excavate those in the future. I found that the EM38 and the magnetometer worked well together because they both do slightly different things, and it gives you an idea. It allows us to hypothesize what might actually be down there. But it also produces a lot of data, and even though that is promising when you have a lot of data to go through, it also means that you really need to have a lot of practice with the equipment that you're using. You need to be able to sift through large amounts of data in order to be able to make any sense of what's going on. So what we did was we went back to this site and we excavated there the following year, and we excavated some of those areas that looked most promising. And I won't cover that now because we'll discuss excavation next week, and so I may get back to it then. I just wanted to give you an example of a geophysical survey with specific goals in mind and how it's carried out. Things to remember, I guess, are the setting where we were and the types of instruments that we used. And I can do a little write-up where you can watch this online and get that information out of there. What were some of the things that we discovered, and how useful, how it saved us a lot of money, saved us a lot of time, but at the same time, we had to be careful with our results and not get too excited, because we still, when it's all said and done, when we came out of the field this year, we hadn't actually found anything. We had only got some leads on what might be down there, and we still would have to go back and excavate. All right, so that's more or less all I have to say about this particular project. You guys have any questions or comments? No? Okay, well, let's just stop.